Let's see together the standard normal curve. What is the standard normal curve? It is the curve of the normal standard distribution that has mean 0 and standard deviation 1. The specific curve is extremely important and it has its own name. It's called bell curve because we have information about the probability for each one of the z-scores. What are the z-scores? The z-scores are the numbers that lie on the x-axis. They start off negative 3.89 on the left and they go up to positive 3.89 on the right. So if you have any z-score, it doesn't matter which one, and it's somewhere there, then if assume that the z-score is 2, the corresponding probability for 2 can be found in the z-table, and this probability will be nothing else than the area that is right here, yellow. It's always on the z-table, you will find the area to the left of the z-score. Now, one thing that I want to make sure that you understand is that I want you to use this table and not the table that the book gives you. So the table that you should be using is this one. This is a complete table and you can find everything on this one without manipulating the numbers. So the first thing that I want you to see is that on the left side we can see the first column to have numbers from the negative 3.4 down to negative 0, and on this side we have another table that has the positive z-scores from 0 to 3.4. Again, one more time, how do we read z-scores? Okay, if your z-score is the 1.01, then you should be looking at the row that starts with 1.0 and at the column that is at 0.01. Why? Because you have to add 1.0 plus 0.01 and this will give you your z-score, that is 1.01. The corresponding probability for the z-score 1.01 is going to be the number 0.8438. What is this probability? This is the probability, the area of the curve to the left of the z-score 1.01. Okay, let's see a specific problem together. Now, again, this is what we have. Assume that we have a problem. What problem? Let's see one. Suppose that you want to find a jar of peanut butter contains 453 grams with a standard deviation of 10.6 grams. 10.53 grams is going to be your X bar, the mean for the jars. The standard deviation is 10.6 grams. You want to find the probability that the jar contains less than 450. Less means less, smaller than whatever numbers you will calculate. The first thing that you want to do is to calculate the z-score for those numbers. For mean 453, standard deviation 10.6, and x 450. Okay, so what do you have? You have your formula. The formula says that the z-score is always equal to x minus mean divided by the sigma. Okay, this is what you know. Perfect. In our case, the x is 450. The mean for the jars, for the weight of the jars, is 453, and we have to divide this by the standard deviation that is 10.6. So we have negative 3 divided by 10.6. Negative 3 divided by 10.6. Let's do that. 3, sorry, negative 3 divided by 10.6, that is the standard, negative 3 divided by 10.6, that is the standard deviation, give us negative 0.283. Negative 0.283. This is the number that we have. What is this? This is our z-score, negative 0.28, since the 3 cannot be shown on the z-table. Okay, you split this number. How? You have to split it up. Negative 0.2 and 0.08. You are going to look at the row that starts with negative 0.2 and at the column that starts with 0.08. This is your table. You're looking at the table with the negative values. Since your number is negative 0.2, that is going to be somewhere here, right here, negative 0.2, and you're looking now at the column that starts with 0.08. 0.08. So let's find the corresponding value for negative 0.28. The corresponding value is right here. It's the number 0.3897. 0.3897. 0.3897. What is this? This is the probability that your x is less than 450. This is your probability. 0.3897 is the probability that your x is less than your z-score, that is negative 0.283. But this corresponds to a jar that has weight 450. So that's your probability, 0.3897. This should be the answer that you are going to enter in this problem right here.